Okay, this lesson is on compound inequalities story problems. I didn't get that into the title, but that's okay. We're going to look at how you can write compound inequalities when you're given a story problem or a sentence. We're going to start with a couple of just simple ones. So let's look at example number 1. 9 less than a number is no more than 8 and is no less than 3. So that's kind of complicated, but let's just go through. So I'm going to put a part A up here. It says write a compound inequality. Be sure to assign your variable. So let's assign our variable up here. So let's say that n is the number that we're looking at. Okay, just to make sure we know what our variable actually means. So we have 9 less than a number. Let's just start with that piece. So if I take my number, I will have 9 less than that. Is no more than 8. So is no more than 8. So if it's no more than 8, that means it could be equal to 8, or it might be less than 8. Okay? And then it says, and is no less than 3. So I'm going to move my part A right here so I have room. So it's no less than 3. So we could do that by putting in this less than or equal to sign. So it's no less than 3, which means that this has to be bigger than or equal to 3. This part's bigger. The 3 is smaller. Okay? So that's part A. And then part B says to solve it and write your solution out in words. So to solve this, we're going to try to get n by itself, which means I need to add 9 here, which means I need to add 9 here, and add 9 over here. Remember, on these 3-part compound inequalities, we have to add 9 to all 3 parts. So 3 plus 9 is 12, less than or equal to n, less than or equal to 17. And so we solved it. This is my solution. We wrote the compound inequality. And then we're going to write the solution out in words. So if we go back, it's, we're looking for basically that n is a number. And so we would say that the number is between 12 and 17. And somehow we have to talk about those equal to signs. And so there's a fancy way to do that. You say inclusive, which means that we're including the 12 and we're including the 17. It gets a little trickier if you're only including one and not the other, but that's how we can say that nicely. You could also say that n is no more than 17 and no less than 12. You could use the wording that they had back up here in the original problem if you wanted to, and just switch those numbers out. There's lots of ways to write it. I like using the between because that's just what it looks like on the answer. N is stuck between 12 and 17, but we are including the 12 and the 17 using those equal bars. All right, let's take a look at number 2. The sum of 4 times a number and 8 is between 0 and 12. So I'm going to let x be my number this time. Lots of people like to use x, so I'll use it occasionally. So it says the sum of 4 times a number and 8. So 4 times a number would be 4x, and 8, if we're doing a sum, would be plus 8. Or you could do 8 plus 4x. It doesn't matter as long as you have that sum in there. So this is the sum of 4x and 8. Is between 0 and 12. So if you think about that, put 0 on this side, 12 on this side, and we'll use less than signs to relate to that. It's between 0 and 12. 0 is the smallest number, 4x plus 8 is the middle number, and then 12 is the largest number. And it does not say that it's inclusive, so we're not going to use equal signs there. If it had said inclusive, then I would have equal signs. If it said including 12, I would have an equal sign there, but it doesn't. Okay, so we assigned our variable like it says, and we wrote our compound inequality, so that's good. Then it says to solve your compound inequality and write your solution out in words. So we're trying to solve for x here. I have 4x plus 8. It's just like solving our equations and our regular inequalities. You start by adding or subtracting. So I'm going to subtract 8 from all three sides, or all three pieces, I should say. So I'll have -8 here. Oops. And just a less than sign will bring down the 4x. And then over here I have 12 minus 8, which is 4. And I'm making sure just to copy down those signs each time. I still don't have x by itself. I have 4 times x. So we'll get rid of that by dividing by 4, which you guys all should know how to do. And that leaves me with x in the middle. -8 divided by 4 is -2. 4 divided by 4 is 1. And so on this one, when we write it in words, you can see that x is between -2 and 1. We can say the number is between -2 and 1. And we don't need to say inclusive or anything like that because that was not included as part of the problem. All right, so those are pretty straightforward. They're not really story problems. They're more just some phrases that we're changing into algebra. The rest of these are story problems. And I'm going to apologize for typos ahead of time. There are several, and I'll just talk you through it. It says each type of fish thrives in a specific range of temperatures. Sorry, it's not in a specific range of temperatures. The optimum temperatures for sharks range from 18 degrees Celsius to 22 degrees Celsius. Write an inequality that represents the temperatures where sharks will thrive. Be sure to define your variable. So since we're talking about temperatures, up here I'm just going to write T equals the temperature. I'm just going to call it temp. Okay? The optimum temperature for the sharks. And so it says it ranges from 18 to 22. That means that T is between 18 and 22. And so we know that we're going to have less than symbols because 18 is smaller than 22. So these all have to be pointing this way. You've got the smallest, the medium, the large. And then we have to think about, are we going to include 18 to 22? Since it says it ranges from 18 to 22, it is my interpretation that we would put equal signs on there, that it's okay if it's at 18 and at 22 as long as it's not going below or above. So this is part A, and there is nothing to solve for there. That's just an inequality. Okay, B says write an inequality. It'd actually be a compound inequality that represents the temperatures where sharks will not thrive. Be sure to define your variable. So we still have the T as our variable. Don't necessarily have to do that again. But if we think about it, if only from 18 to 22 is where the sharks are going to thrive, that's the temperatures that we want. Anything outside of that is going to be bad for the sharks. So if I go below 18, so if I have a temperature that's less than 18, that would be bad. Or if my temperature was greater than 22, that would also be bad. So the temperatures below 18 or above 22, that would be bad. And so there's a compound inequality for this. There's a similar problem on the homework that talks, I think, about growing corn, and you'll have to do the same thing. What are the temperatures that's best to grow it? What temperatures are not okay? And so there wasn't anything to solve on that. We're just writing compound inequalities. All right, let's take a look at number 4. A store is offering a $30 mail-in rebate on all color printers. Yay. Louis, or Louis, however you want to think of that, is looking at different color printers that range in price from $175 to $260. So we've got another range there. Write a compound inequality that represents the situation. Be sure to define your variable. So I'm going to I'm going to make my variable the money spent after the rebate. So I'm going to say X is the money spent after the rebate. So let me explain what a rebate is. So you're going to buy these printers somewhere between $175 and $260, and usually there'll be a piece of paper. It might be part of the box, there might be a little slip in the box. It might be on your receipt if it's a store rebate. And what you'll do is you'll mail that in with your name and your address, and they will send you $30 back. So it's kind of like you're not paying the full price, but you have to wait a couple weeks to get that money back. It's a good deal. So when we're writing our inequality, we want to really think about that mail-in rebate. So when, I'm going to zoom out just so I have a little bit more room here for you to see what I'm doing. So if I'm writing the compound inequality, X is what I'm going to spend in the end, after they give me the rebate back. So the total price is the money I'm going to spend plus that $30 rebate. That's how I am choosing to set up this inequality. And so that is going to be between 175 and 260. That's the range. And so 175 is definitely the smallest, 260 is the largest. So if you're thinking about alligators, the alligators are all eating what's bigger, which is going to go to the right. And so this is what we're getting back, what we're going to spend after the rebate, plus the rebate, because we have to spend that in the beginning. And then we will solve to figure out what that range is. So we would just subtract 30 here, and here, and here. Take off that rebate. And we'll get 145 is less than X is less than 230. Oh, and I forgot to write this in words. Or does it say 2? It doesn't actually say 2, but we'll write it in words just to practice. And so we would say that Luis, or Louis, if you're speaking French, will spend between $145 and $230 after the rebate. And you have to be careful when you're shopping, because sometimes they'll have a price advertised for something, and then in small print it'll say after rebate. So you may have to pay the full price of $175 or to $260, somewhere in there, and then wait to get that rebate back. So ultimately you're not spending full price, but it does take a little bit of time to get that back. Okay, on the next page, number 5 is a repeat. I don't know why that's on there again, so you can cross that off. I know you're sad that I put that on there twice. I don't know what happened. Let's look at number 6. So it says Cindy has scores of 72, 82, 83, and 89 on her biology tests. Use a compound inequality to find the range of scores she can make on her final exam to receive a C in the course if a C is a score of 70 to 79, and the final exam counts as 2 tests. So this is a little bit tricky. So we're looking at 72, 82, 83, and 89 on her tests, and then her final exam counts as 2 tests. So when we're doing things like this, we do an average. I'm going to let E equal her exam score. And remember that it's going to count as 2 tests. So she's already had a 72, an 82, an 83, an 89, and then her exam counts as 2 tests. It's kind of a weird system, but I've seen it done. And so I'm going to add on 2 exam scores. And we would add all of those up when we're averaging. And then we would divide by how many tests that she takes. So 1, 2, 3, 4 tests already taken, and then her exam counts as 2. So it's the equivalent of 6 total tests. All right, and we'll clean that up here in a little bit, but that is how you're going to average her tests. So this is how you would do that average. It's like the good old-fashioned mean that you've done before, where you add it all up and then divide by how many there are. So let's add up all of these except for the 2 exam scores, because we don't know what the exam is. So if I add up 72, 82, 83, and 89, which I did on my calculator, I get 326, and then I have to add that double exam score, and all of that's getting divided by 6. Okay? We know that that is going to be between, we want it to be between 70 and 89. So I'm going to put 70 on this side, 79 on this side. And she's okay, Cindy is okay with it being equal to those scores. So we're going to have a less than or equal to on both of these. If you've noticed, I set all of mine up with less thans just because I like to think of it in the order it would be on a number line, the smallest to largest. It's how my brain works. And so this is our compound inequality that we're going to solve. It looks really scary. What we're going to do to solve it is we're going to multiply everything by 6 to get rid of this fraction, because this is divided by 6. To get rid of divide by 6, we're going to multiply all of this in here times 6, and that cancels that out. But if I multiply the middle part by 6, I have to take 79 times 6, and I have to take 70 times 6 also. So 70 times 6 is 420. In the middle, what we've done is we've just got the top of that inequality by itself. And then I've got 79 times 6, which is 474. All right, so it's getting a little bit easier. We got rid of the fraction by multiplying by 6, and now we just have 2 more steps left to solve. So we're trying to get the part with the e in it by itself. I'm going to leave the 2e alone. I'm going to get rid of the 326. So the opposite of positive 326 is negative 326, or you can think of it as subtracting 326. We're going to do that from all 3 parts of our compound inequality. 420 minus 326 is 94. 474 minus 326 is 148. And then I still have 2 exam scores, because remember, your exam counts as 2 tests. So to figure out what one of those has to be, we would divide everything by 2. So on all 3 pieces, we'll divide by 2. We get 47 is less than or equal to e, which is my exam score, which is less than or equal to 74. So this is giving us a range of what she has to get on her final exam to get a C. This will get her a low C. This will get her a high C. And so we could say she must score between 47 and 74 on the exam. And we could put a little note that that's inclusive. It's okay if she gets a 47. She'll barely get a C. That would give her a 70. If she got a 74, that'll give her the highest C, which is a 79. So that just gives us that range.